So this is now lesson 5, the last lesson for this unit. We're going to be talking about mechanical advantages and efficiency. The reason why simple machines are made is because we wanted to be able to maybe apply less force to do something that is really, really hard, like say lifting a very heavy object. It takes less work to just lift it, but you might not be strong enough to have that force, so it's easier to push it up a ramp. But then at the same time, we're wasting energy. So a good simple machine is that it can save you the force. You can use less force to do the same job, but at the same time, it doesn't waste a lot of energy. Most of the energies are wasted as heat, and for something that has a high efficiency machine, it just wasted less energy of what you actually wanted to do. Okay, so there are going to be 5 different equations to work out what is the efficiency. Okay, so the first one is relating to the law of levers. And what they have done is they've rearranged the equation to make it into a ratio of distance and force. Okay, so if you take a look at this equation, you will not be required to know how the equation come from, but you will need to know how to work out what the equation is. Okay, like how to use the equation and plug in the numbers and calculate the efficiency from it. Okay, so what they have done is there's a DL here, and this is a multiplication, and they move it over and turn it into a dividing. That's why this is DE divided by DL. And then at the same time, they move this one over by dividing. That's why FE is now at the bottom. We call this the distance ratio and the force ratio. So basically comparing the distance of the effort and the load versus the force, they're constant. And we're talking about static equilibrium, but at the same time we talked about that there may be frictions and the ratio sometimes won't be the same. So we're going to use the ratio to calculate how much is it wasted. So you will need to know, or well, you can write it out. You need to know what actual mechanical advantages. So on the test, I will expect you to be able to pick out. If I say AMA, you should be able to tell me that that's the actual mechanical advantages. And the equation for that is FL over FE. Okay, and then we have this thing called the ideal mechanical advantages, IMA, which is the distance ratio, right? As I said, you're going to write them all out. And this is only for one machine. Okay, this is only for the levers, but remember we talked about many different kinds of machines, and you will be using different ratio because they're not all length, right? So for levers, you would be, to calculate IMA, it will be DE over DL. Wheel and axles will be the radius of the two wheels, the effort wheels and the load wheels. So if you think about your bicycle, right, when you paddle, the like kind of the ratio between the radius. Gears, you talk about the teeth count. So basically how many, like, you know how like your gears have like little teeth, and then you will have this, and then it will be locked in with another wheels that maybe is a smaller with a smaller teeth. I'm so sorry, they're supposed to be locked together. So the number is the actual number counting the number of teeth. Like I'm actually counting how many teeth there are, and that's where these number came from. Pulleys are talking about number of supporting strand. So basically any string that are pulling upwards. If I have a pulley and then I have a string that I'm lifting upward like that, I actually have 2 strings that are pulling it upwards, right? Because as this thing keep pushing up, do you see how the other string would shorten and also lift it up? So to find the IMA for a set of pulley, we count the number of strings that are going upwards. And finally, if it's an inclined plane, we would find the length of the inclined plane compared to the height. What the height means is if I draw an inclined plane like this, okay, this is the length of the inclined plane, right? But then this is the height. The height is what you actually wanted to do. Remember how we were saying lifting a piano at the back of the truck? You honestly just wanted to lift it with the height, right? You just wanted to move from the ground to that, but you're taking the time and pushing it along L because you don't have as much of a force to do it one time. So I'm gonna include the AMA. So remember that to calculate AMA, we're always talking about the force, right? FL over FE. Okay, and these are all the equations plus the efficiency equation that you will need to know. You always find your AMA using this, your actual mechanical advantages. IMA depends on what objects or what simple machines you're using. And then after you find that, this is how you calculate the efficiency. Okay, percent efficiency is AMA divided by IMA. If you have low friction, you have a higher efficiency. So let's look at an example. In an acrobatic move, a person jumps onto the end of a plank, a lever. It creates a large effort force of magnitude 920 newtons at the end of the board at a distance of 1.7 meters from the fulcrum. Okay, so we have an effort force of 920 at the end when it is 1.7 from the fulcrum. Okay, and then you have a smaller person of a mass of 47 kilogram. He is located 3.1 meters from the fulcrum. Is launched into the air to perform the thing. Okay, so we will need to calculate A, the AMA, B, the IMA, and the percentage efficiency. So taking a look at it, it's a lever. So I know that every time when there is a lever, there is a fulcrum. So I'm just going to draw a fulcrum there. And it tells you that you have an effort force of 920. So I'm just going to go downwards. And I'm going to say this is the effort force, FE, going 920. It does help if you draw a picture. Okay, at the end of the board, 1.7 meters from the fulcrum. So this, the distance from the effort, so DE, to the fulcrum is 1.7 meters. And then they tell you that you have a small person, but this time they give you the mass. Okay, so hopefully you know that you need to convert that into a force. So that means this is your load, right? This is what you're trying to lift up. So I can work out what the F load is, and I'm giving the mass, I times it by 9.8 to get the force. So I'm just going to do it on the side over here. So 47 times 9.8 is equal to 460.6 newtons. So this is my FL. Actually, I'm just going to erase it from here. And I'm going to put down that the FL is 460.6 newton. So that's, I'm just going to write that the mass. I'm going to put it up there just to show the calculation. When they give you a mass, you calculate the force by multiplying it by 9.8. You've learned that when we work out the weight in the Newton's law, right? Okay, and they tell you that this 47 kilogram person is located 3.1 centimeters from the fulcrum. So DL is 3.1 meters. And so letter A is asking you to calculate AMA. So go back to the equation. AMA is FL divided by FE. Okay, so throw your numbers in. FL is 460.6 and FE is 920. So 460.6 divided by 920, 0.501. It doesn't have a unit. Okay, because both are Newton, so Newton divided by Newton is canceled out. Okay, so there's no unit for the AMA as well as the IMA. We're going to see that afterwards. Okay, second question asks you for IMA. So having the chart in front of me, I'm dealing with levers so that I know that to calculate the IMA, I have to go DE divided by DL. So do you understand when we're doing our test, make sure you have all your equation in front of you, right? Like with the chart, easy access to it. IMA is DE over DL. Okay, so DE in this case is 1.7 meters. DL is 3.1 meters. Punch that in your calculator. 1.7 divided by 3.1. 0.548. I'm just going to keep 3 decimal places. And then they're asking you what is now the percent efficiency. So percent efficiency, now you go back to the equation again. Percent efficiency is AMA divided by IMA times 100%. So AMA divided by IMA times 100%. So So I calculated AMA to be 0.501 divided by the IMA that we found from part B is 0.578. You still have to copy this out, right? Times 100%. So punch it in the calculator. I still find that sometimes people have a hard time. So you literally would punch this in the calculator, and then whatever that number is the percentage. Okay? So 0.501 divided by 0.548 times 100, 91.4%. So that's the efficiency. Okay? Meaning 91% is still used to lift this person up. There's some forces that are lost. That's why it's not 100% efficiency. We've lost some effort force, but that's okay. All right. Number 2. A 14 Newton car is pulled 1.2 meters up a ramp with the effort force of 5, parallel to the ramp, raising the cart 0.4 meters above the initial level. Okay, so let's see, calculate the IMA, AMA, and percent efficiency of the ramp. This question is a bit more tricky because you need to figure out what your length are and all those stuff, right? So let's take a look. I have a ramp. Oop. The ramp is 0.40 above the initial level. And they tell you that you have this 14 newtons cart. 14 Newton. Let's write. I'm gonna write 14 Newton because it's a force. I know it's a force, but my question for you is 14 Newton the load or the effort? Sometimes we're not sure. You can keep reading and use process of elimination. Do you see how later on they say the effort force is 5? So the actual effort is 5. So if that's E, does it make sense that the 14 has to be the load? And then it tells you that if this 14 Newton cart, this is your FL, which is 14, and it moves it for, this is your DE, the distance of the effort, because you would push it 1.2 meters long, and then you have raised it, so this distance is the load distance. Like you actually want to lift it up with the height. All right, so you're looking for A. What is the IMA? Okay, so go back. Is it ask? Yeah, so go back to IMA. This is still a ramp, meaning a levers. And DE over DL. Okay, 1.2 meters divided by 0.0 meters. 3, part B, what is the AMA? AMA equation is FL divided by FE. FL is 14 Newton. FE is 5 Newton. 2.8. No units, right? Remember, no units. They cancel. Okay, last one. What is the percent efficiency? Go back to your equation again. Percent efficiency, AMA divided by IMA times 100%. Okay, so AMA, we found it to be 2.8. IMA is 3 times 100%. So 2.8 divided by 3 times 100, 93.3%. So the percent efficiency is 93.3%. So it's pretty good.